everyone. Thanks. It's really great to be here. A little bit about me. So I work for Cordoba. I'm head of data science there. And I used to work for Idibon, which was a company that did NLP models as a service. So my background is in NLP. It's something that I really love, that I've always enjoyed doing. And I got into distributed systems because you can do a lot more with NLP if you have a lot more machines to work with. So it was a very natural progression for me. And I also really like emoji. I developed this deep appreciation for emoji while I was at Idibon. And so you'll see a lot of emoji here. Specifically, the emoji one is my favorite set. So quick bio. The reason I'm here, the reason I'm at Cordoba is because I have this deep interest for languages. I, as a teenager, learned a second language, not because I had any particular heritage associated with it, just because I was interested with it. And I also have a very technical background. Both of my degrees are computer science, and so it makes a lot of sense for me to be working at Cordoba with these multilingual technologies, because it combines two of my biggest interests. So because I've been working with multilingual technologies for a while, a lot of people, I think I'm working on a universal translator. That's not what I'm working on building, although that would be pretty cool. Clearly, I'm saving the world on an everyday basis. What I actually do is what I'm here to talk to you about. So just as a quick summary of what I'll be talking about. Okay. Quick summary is, so what we do at Cordoba, the whole company mission is to help companies build products that feel native, regardless of what your native language is. Pretty much everything out there is in English, and so we want to make it so easy that it becomes default for anyone building any type of product to release that to markets other than English-speaking ones. And the localization industry is one that hasn't really changed much in the last 30 years. And we think that there's a better way to do it. Spoiler alert, it involves MLlib. And I'll specifically be talking about my project, which is affect detection, and I'll tell you why I'm so excited about it and why it's so useful for us. So if I could describe Cordoba in just a few words, I would say that it's kind of a comparison. If you think about what Docker did to deployment, this is what we're trying to do with content, really sort of separating it out into a completely separate layer. And what that gives you is it takes out all the impact on your core application logic. So if you think about it, you have your bottom level is your bare metal, your machine images. And then on top of that, you have your containers. That's where you have everything packaged up into a Docker container. On top of that, you have your application logic. That's an application as you would think about it today. Everything that drives your product, all of the special things that it does. And then completely separate from that, we see the content layer. So anything that has to do with text, images, video, anything that's not core to that application logic, we see advantages of pulling that out. And that's how we make it so easy to globalize a product. Because if that's completely separate, just like with Docker containers, it's a lot easier to plug and play. So a little bit about what localization looks like right now. It's really complex. It involves a lot of humans and a lot of communication between those humans. These are humans in different departments. So there's engineering involved, there's marketing, there's product managers, there's also linguists, people doing the translations themselves. And there's a lot of files flying around in between these departments. And the goal is really to, we've all seen the results of that. If anyone has used a product in any language other than English, it leaves a lot to be desired. If anyone remembers the Got Milk campaign from the 90s, it was wildly successful in the US. And the American Dairy Farmers Association decided that they wanted to expand that into another market. They brought that into Spanish-speaking markets, and the translation was roughly equivalent to, "Are you lactating?" That's less than ideal. I'm sure it didn't help them sell any milk. And I'll show you an example. I want you to think about how you would localize, how you would globalize this ad. So this is a company I believe they're a fashion company, and they're selling cell phone covers. And this is a really powerful ad. It really speaks to you. You understand it immediately. It's pretty effective. But it also has some cultural references in it. It has very specific things that are specific to American English and sort of pop culture here. And so if you wanted to bring that into, say, the German market, you might end up with something like this. It's okay if you don't know German. It's roughly equivalent to I realized that when this telephone service flashes, it can only mean one thing, which doesn't have that immediate impact. It's really less effective as a marketing tool. And so these are sort of the challenges that you see with trying to localize things. So we see a lot of problems with that, and we think that there's a better way. So what does that better way look like? Well, we want to automate things. What we're doing is taking concepts that are very well developed in other areas, like engineering, so continuous improvement, continuous deployment, continuous delivery, all of these things that are sort of accepted best practices haven't necessarily translated, made their way over to localization yet, and so that's what we're doing. And the idea behind it is that we have an SDK, and you put that into your application, and you essentially point to a dynamic link in the cloud, and then you can update that target from any other location. And what that gives you is live updates. It gives you consistency among mediums, so that whether it's your website, your iOS app, your Android app, your print media, let's say you have a Photoshop design, all of that remains consistent because it's pointing to the same place. And if we change that from the web application, then your app reflects that change. So it's a lot easier to maintain, and it gives power to marketers in terms of the, what's contained inside that content. Because as an engineer, the way it works now is that a marketer sort of asks an engineer to deploy it, and an engineer kind of gets bothered by that. They don't really like phone calls or emails, and the marketer gets a little frustrated because she has to ask for permission. But if this all happens automatically, then it sort of puts control in the right hands. So the other thing about that, I had a conversation just this week with a very large company with a ton of web properties. And I asked him what his biggest pain point was, what one thing he would change about his localization process. And he told me that it was context. He said that he had a ton of problems with getting screenshots to make it to linguists and to keep things together and for it to all make sense and for the linguists to understand what they were translating. And that's the other advantage of this, is that it's sort of a live editor and you're making a translation in the format that it will end up in, and you have complete control over the length of things and all that. And then my personal favorite is the GitHub integration, because this enables you to put everything in Jenkins and really just deploy things pain-free. It's less work for engineers. Everyone is happy. So example time. Let's say that, so this is a picture of my neighborhood. This is Dolores Park in the Mission. It's in San Francisco. And this is a pretty typical scenario. It's a really busy urban park. It's beautiful. The weather in San Francisco is amazing in months other than February. This month has not been great. But let's say I am a produce vendor. I don't know, Imperfect Produce. They're great. If you haven't tried them, you should. So I want to sell more fruit. And so I come up with this beautiful, effective ad, and I go to this billboard company, and I tell them, look, I want you to put this billboard out there. They're an electronic billboard company, so they press a few buttons, and there you go. It's deployed. And I start selling a lot of fruit. I see a big bump in sales, and I'm super happy. So I decide, okay, I'm ready to expand. Let's go into Chinatown. It's also a really dense urban environment. I'm pretty familiar with the area. Let's put that same ad out there. So I call up my electronic billboard guy, tell him, let's take that ad and deploy it here, right at the entrance to Chinatown. He's like, okay, no problem, does it. And I don't see that bump in sales, and why not? Because it really doesn't speak to the Chinatown crowd. What am I gonna do about that? Well, I'm pretty familiar with the area, and if anyone is familiar with this story, it's really not so important. It's hilarious if you wanna go read it. I tweeted a link to it. I won't go into it into too much detail, but so this is Brother Orange, and it's this really hilarious story that represents, it's symbolic for friendship between China and America. So this is a pretty good candidate as a produce vendor, Mr. Orange. Let's have him telling people to buy things. And I think that that might be more effective. So I go back to Mr. Billboard guy, I say, all right, I want you to deploy this, take out that other one, put this out there. It's wildly successful, it does fantastic. And then I decide, okay, these two are successful, I'm gonna continue this pattern. How do you do that in neighborhoods that aren't your own, that you don't spend time in once a week? How do you do this across the country in areas that you're not familiar with? So the billboard company isn't gonna do that for you. It's still your content, you still own that, you have control over it, but it's a lot more difficult to manage as you try and scale it up. So that's the problem that we're trying to solve here. And the way we're trying to do that, it's not just on a per language basis. It's not like we want to put English here and in Australia and in the UK and have it all be the same. We really want to localize, not just in terms of physical location, like Mission versus Chinatown, but also in terms of domain. So it's really containers all the way down, if you think about it. We want to have, if I'm writing obituaries, I don't really want to have anything from social media that creeps in to there. So that's the big problem, the larger context of why we need affect detection. So what exactly is affect detection? It's kind of a fancy term. It's okay if you don't recognize it. It's just generally emotion detection, and it's looking at the emotion that's associated with any given piece of text. And why is this so important? Because remember that we want to put everything in Jenkins. We want to automate that entire pipeline. We really want to get to a point where we have some, not all, but really hands-off translations. We want to have models that are so good that our users trust them. And that allows us to really transition through those workflows in a way that gives our users enough confidence to deploy things live without having a human look at it. We don't want to do that all the time, but in a lot of cases, if we can provide the emotional context, it can help that process. And I'll explain a little bit about why. So if you think about, this is a sentence that we put through our affect detector. Very simple, very basic. What would you expect to come out as an emotion associated with this piece of text? Think about, I don't know, happiness, sadness, anger, embarrassment, thankfulness, whatever. You know, think about what you would expect to see. Any guesses?
Could be any of them.
What would you expect? So this is trained on a corpus. Like, what do you think would be out there in the literature? So this is romance. Okay. So that's less of an emotion, but romantic, that could fit. Turned out to be a very interesting answer, which tells us something in and of itself. You know, that's pretty interesting. So we changed it up just a little bit. We changed only one word. We didn't even change the gender, but we got a very different response. And the emotion associated with that is very different. So let's look at a translation example. Let's say I'm at Imperfect Produce, my business is booming, and I can't handle it. So I'm looking for help. I put out an ad, but I'm headquartered in the Mission, and so it's a lot more effective if I have a Spanish version. So the English version might be associated with, let's say, sadness, I'm overworked, I need someone to help me. And the Spanish version that my translator comes up with is roughly akin to like, get off your lazy ass and go get a job, which is a very different emotion. And if I'm looking for help, I'm probably not going to get anyone Spanish-speaking who responds to that. This is another example of, let's say so I live in San Francisco, my rent is outrageous. I put up my property onto a vacation rental site. And I get a lot of American tourists who come because it's in the Mission. It really is a killer location. It's amazing. It's on Valencia. So the language that I studied when I was a teenager, the one that I learned was German. And so what I really want is not the Americans coming to my house. I really want Germans to come because I want to practice with them and I sort of miss it. It was over a decade ago. I would really like Germans to stay at my house. But when I click that German button on that site, this is the translation that it gave me. Diese Wohnung befindet sich an einem mörderischen Standort. Mörderisch means the same thing in German as it does in English, which has a very different meaning and really doesn't make me want to go stay in that place. So this is why affect detection can be really, really important and really helpful for automating that pipeline. So this is what I set out to try and build, and these were the requirements. This is what I was looking for. It had to fit into the larger platform. It's built up of microservices, and so it had to have a REST interface, something that the other services could call and get an answer quickly from. Response time was really important, and obviously it had to be scalable. The thing that I really love about working for a startup is that we made a lot of our architectural decisions just a few years ago, and so we were able to pick really great technologies, things that work well together, that are very scalable, like Spark and Cassandra, and lots of things that are sort of proven by now. So it had to be scalable, not just in terms of deployment, but also it had to scale out to different languages. You can't use the same model on on every single language, and we support them all. And so it also has to support those mini containers. So we wanted lots of different models, not just as many as there are languages. And it had to be useful because it had to be accurate because if it's not accurate, it's not useful. We wanted our customers to trust these results, and it's really just another data point, so it doesn't have to be perfect, but it does need to give us an indication of the quality of our translations. And we all really care about open source, so that was a priority as well. We wanted to be able to open up this repo because affect detection is a very specific thing, and the way we've built it is not to just do that one thing. We've really built it as sort of a generic classifier that you could put in really any label. It doesn't have to be emotions, but there are a lot of things involved in that. There are a lot of steps. And let's say tokenization. It's decent in English. It's not bad at all, but if you try and do that in Arabic, it's really terrible. But we have an Arabic tokenizer, and that is something that's really useful in so many contexts. It's not really like a competitive thing that we need to keep. It's something that we really want other people to use in order to build products that support Arabic. So open source is really important. These are the things that I had in my head that I had to have this product do. So I mentioned that I was at Idibon previously, and this is another San Francisco startup, and we had this amazing platform. It was this really powerful machine learning service that I could just do so many things with it. It was flexible, it was fast, it was scalable, and I really missed it. It's not running any longer. I didn't really have access to it. So here I was, this sort of spoiled itty baby, really wanting to use this system. But I was on the engineering team, and so I knew how it was built. I knew what went into it. I knew that I didn't need all of it. I needed some very specific things just to build affect detection. And so, of course, as an engineer, I'm going to build it myself. But don't worry, it's not from scratch because MLlib is going to be doing the heavy lifting. That's going to be doing the algorithmic stuff. And that's really the core of machine learning, right? So my idea was to go about building this thing, and you can imagine, I'm sure you're all familiar with this, I set out after a few months and really found myself operating in the top half of that diagram, and I didn't have anything tangible, and I had spent months on this thing, and it was really frustrating because it was a lot more involved than I had expected. And so I realized that was not the approach. The day that I was looking at a PR that was trying to solve a pretty simple ticket. It wasn't a huge feature, but it involved like 15 file changes. And looking at that, I recognized that there was something wrong with the design, that it was time to take a step back and really look at things and look at what was wrong with that design and how it could be made better. Because if you're having to make 15 file changes for a simple feature request, you're not doing things right. So taking a step back, I looked, not just at our code base, but I happened to notice that Christmas had come early because Predictionio had entered the Apache incubator. So this was this sort of gift-wrapped, existing open source community, one that I didn't have to build myself. And it already provided so many things that I needed, like that REST interface, the response times. It was scalable, more scalable than I even needed. And once I looked inside the code and looked at what was involved in developing something on top of that framework, I was really impressed. It was like being in an episode of Blue's Clues where the mailbox is called Mailbox and the two things sitting on the table are Mrs. Salt and Mr. Pepper. All of the objects were very easily named, and it was just so well separated that within like 48 hours, I was able to come up with a product that admittedly only recognized emotion on Simpsons quotes, but was useful and gave me that sort of, it put me back in that bottom half of that diagram instead of being at the top half. So I sort of made this proposal, okay guys, I really think we should step back and start using this other platform. And you can imagine, if you've ever met an engineer, they don't really like to get rid of things that they've just built. And so there was a lot of pushback, and that was completely understandable. There was a lot of pressure to not go this other route and to just build something from scratch. But ultimately, even though we sort of archived all that code and sort of wrapped it up neatly and put it on a shelf, it's something that we've also referenced in the past few months, and we've still taken parts of that and found it very useful within Predictionio. So it wasn't a complete loss, it was just a little bit of a challenge, but absolutely the right decision, because we found ourselves, instead of having this like Rube Goldberg machine with triangular wheels, we had something more akin to a bicycle. And that was really useful because that meant that we could really focus on the hard parts, like the model building, the featureization, training data, all the really tough parts, and we didn't have to worry about any of the framework surrounding it. So what exactly does that bicycle look like? Does anyone remember the scene in Apollo 13 where they lock all the rocket scientists into a room and they tell them, look, this guy's life is at stake, you need to save his life, and this is what you have to do it with? So it felt kind of like that. Predictionio there are a lot of components. It's scalable, so you can use a lot of different things to make it work. And in a more organized way, this is roughly what it looks like. So you have, your compute is completely separate, so you're running all this on a Spark cluster, and that can be standalone, it could be on Yarn, it could be Mesos, whatever you want. And then you also have your storage layer, which is just some sort of existing backend storage layer. It could be Cassandra, it could be Maria, MySQL, Postgres, whatever you want it to be, that's completely separate and configurable. And then you have your sort of model, your engine, and that's sort of the core of what does your training, prediction, all of that. And that's pretty easily scalable, all of those components. It's just sort of a lot of pieces. Okay, quick check with the audience. I want to know, I'm going to go over these 5 things about NLP, and I want to get an idea for how familiar everyone is here with NLP. Feature extraction, training prediction, cross-validation, hyperparameter tuning. How familiar are you with that? If you're familiar with it at all, raise your hand, and I'll know how much detail I need to go into. Awesome. You guys already know everything. That's great, because we're running out of time. So I won't go into too much detail, but this is roughly what an NLP process looks like from a high level. This is your 2-minute introduction to NLP if you didn't raise your hand. So the first, in essence, it's all about just taking text, turning that into numbers, and then using math to get something useful out of those numbers. So you have the feature extraction phase where you actually turn it from text into numbers, and then you have your training portion which is where you fit it to a model and you work out coefficients. And then your prediction step is where you actually get what you're looking for out of it on unseen data that you haven't trained with. And once you get that prediction, you have no idea how good it is, and so cross-validation helps you understand how good the models are that you built. And if they're not very good, you can go back and tweak some of those parameters. That's what hyperparameter tuning refers to. And so you can sort of go through that loop as many times as you need until you have a model that does what you need it to, that's as accurate as you need. So I'll just sort of briefly go over, this is a really simple example of what feature extraction might look like. Very simply, you tokenize that, you would use n-grams and count it all up. That's where you get your vector. That's a native ML-lib BLAST vector, just very simple. And the training portion is where you add a classification to it, and that's turning it from a vector into a labeled point. You send that into Spark's logistic regression function, or any of them that you want, and you deploy that. Predictionio literally has a deploy command. And then for the prediction component, you run it through that exact same featureization pipeline. That's the exact same diagram that we just saw. And you send that vector into your deployed model, and it will give you a label. It'll give you a prediction. And that's what you use to integrate into your application. So it's a prediction component. Cross-validation is going through those steps over and over again. So standard is tenfold. What you do is you take your training set and you split it up randomly. You sort of shuffle it, you get a random set of it, and split it into, do a 70-30 split, build a model on the 70%, and then verify the accuracy on the other 30. And you can use that to see how well it's working, change your parameters, and sort of adjust as you go along. So what does that featureization step look like, specifically in our affect detector? It's dead simple. It's not doing anything fancy. I mentioned that it was working on Simpsons quotes, right? Like, it's nothing sophisticated. It's not complicated. But it's, obviously, we're working with multiple languages, so UTF-8 support is a given. And it's really looking at term frequencies. This is our bag of words model. This is n-grams. It's nothing too complicated, and it's simple to do just with Scala. You don't even need to go the Spark route other than just using RDDs. And the training portion, we're using supervised models because I have a sort of classical NLP background, and those are really proven. They work really well, and I used a lot of them at Idibon. They work great. So logistic regression, just standard logistic regression, is working really well for us, and it's really as straightforward as it sounds. It's using the standard Spark libraries and getting standard results out of it. One of my favorite parts about this project is how we put together that training set. In order to do supervised learning, you have to have that labeled point. You have to have sort of an answer key, if you will. And we wanted this, again, it has to be scalable, and it has to work on multiple languages. So we auto-generated this. There's this Google API call that you can make. It's like a Google Vision API where it takes a photo and it will give you an emotion attached to that. So we're essentially bootstrapping off of someone else's supervised model by taking YouTube videos because they have transcripts associated with them. And it's all sort of time boxed, so you can very easily just sample at whatever rate you want from that video and take a snapshot and take the associated text that goes along with that and send that to the Google Vision API, and voila, training data. And there's a lot of videos in different languages, and not all the transcripts are very high quality, and so we're pretty picky about what we'll take and use. And this isn't human curated data, so we don't trust it 100%, but it's a really great way to automatically generate a ton of training data and be able to get emotion on Simpsons quotes. So the prediction stage in our affect detector is it goes through that same featureization step, and then it routes it. So we have a different model for each language, and Predictionio doesn't really have any routing capabilities. It just sort of lets you deploy a model that you have and specify a port number. So we have a router functionality, just a really simple play framework, dumb sort of port lookup functionality that takes in a request, looks up the machine number, the host name and the port number, and then goes and makes that prediction request. And we can ingest those requests either via REST or PubSub. The Play framework makes that really simple, and that's very much in line with the way our other microservices work. So that's a prediction phase. Cross-validation, we've already kind of gone over this. There's something called the Valuation Object in Predictionio that you use to look at your F-scores, your area under curves, area under rock curves. All of these scores, you can sort of customize what that looks like, and there are a ton of templates out there that give you an idea of how to do that. That's what it looks like for us right now, but obviously I have big plans. This is something that I really enjoy doing, and so what's next for us, that next stage, that motorcycle phase for us, is really having more sophisticated featureization so that we have a lot more options for how we want to train our models. And right now, we're just assigning a single emotion. It would make sense if we were able to assign more than one, because sentences are not, it's not mutually exclusive. We also want to be able to assign confidence scores to that so we understand which is the dominant emotion and how they interact. Logistic regression is great, but it's not the only thing, and so adding a lot of other algorithms is really simple, and it's literally just calling those MLlib functions and building classes around that. So random forest would be a perfect addition. That's next on the list. And other than F-score, there are a lot of other things we could look at that would be really helpful. And obviously, we want to automate a lot of that hyperparameter tuning so that I'm not sitting in front of my laptop changing parameters myself. We want our model to do as much of that as possible. And it also might make sense, instead of just a traditional classification, to maybe look at this as a graph problem and look at how emotions are related from a more relational perspective. So that might be another approach to take. We also want to be able to look at different sources for generating our training data and different ways of filtering them to get maybe just the higher quality pieces of that set. And obviously, it goes without saying that deep learning belongs here somewhere. That's next on the list. Again, classical education, supervised models are great, but deep learning is definitely worth looking at. And then also, we don't just want it to be affect detection. We really want to be able to do a lot more things with it, and the way we've built it, the way Predictionio lets you do things, it's very generic. You can reuse classes, and all you really have to do is give it different labels, and it can do whatever you want it to do. You just have to give it the right training data. So that's basically it. Just wanted to, the main message here is just that there's really a better way to internationalize your products, to do globalization. And hopefully I've convinced you that affect detection is awesome, so that when someone asks you what you want to do tonight, it's affect detection. So that's all I had. I think we're out of time. I don't know if we have time for Q&A, but I will be around, so if you don't get a question up today, please come and find me. I really love meeting new people. So any questions that you have, I'm more than happy to answer in person or just on Twitter or whatever. Just reach out to me, and I'm more than happy to talk to you.
We can take a few questions real quick. We've got a little bit of a break, so I'll take a few questions, Michelle, and then let's give Michelle a round of applause. That was great. It does sound like you're creating a universal interpreter there. I'm actually, as a software developer, that's fascinating, right? Because you can roll all your stuff out. Go ahead with your question.
How many unique affects are you detecting?
So right now we're limited, because we're using that Google Vision API, we're limited to what they give us, which is I think 5 or 6.
So at that scale, if you want to be able to find multiple emotions, you can essentially train a presence or absence binary classifier for each and build your own ensemble to figure out which ones are high enough confidence to include. And so you can get multi-affect detection just by a custom layered ensemble.
Exactly. And the good thing about the Google Vision API is that you're limited to those 5 things, but it gives you a confidence score. So we can still use that with our multiple binary classifiers.
It becomes a feature of the second part of the ensemble to decide whether or not you should include and how many of them you should include based on how they scored.
Exactly.
All right. Well, it looks like we don't have any more. Oh, yep, one more over here. Go ahead.
Thanks for your interesting talk. You started the talk, though, by saying you wanted to make localization automatic. And I missed a connection there, because you're doing affect detection, but that doesn't immediately lead to word sense disambiguation. I mean, if I've got an adjective like hot, which could mean it's hot outside, I'm eating hot food, that person looks sexy, those aren't necessarily things that you get from even a more robust affect detection. And I mean, that's some of what's happening in deep learning now, and they're only 60% good. So how do you make this automatic so that you're actually doing translation automatically?
Yeah, that's a good question. I should have expanded more in the beginning. So this is really just a data point. So we already have this platform that does the machine translations, and it's essentially a web front end for a lot of different people to use it. So your marketers, your non-technical people, your linguists, everyone is sort of going through this workflow stage. And so what we want to do is add affect detection to a certain point, because if I'm a marketer and I come up with that Hotline Bling ad and I say, okay, go make me a Spanish version, and I get one back, maybe I don't know Spanish, how am I going to approve or deny that? It's ultimately my decision whether I want to deploy that or not. And so having that extra data point of what affect is associated with those, remember back to the examples of how they were so different, that's an indicator that we should take another look at it. It's not necessarily that it's a bad translation, but that's an indication where if we had affect detection and all of that matched, that's where we would sort of automate those things and flag the things where there were discrepancies. So it's not the be all and end all. It's not what gives us the word sense disambiguation, but it's just an extra data point in order for our users to trust that automation.
All right. Thank you very much, Michelle. If you guys have questions, she'll hang around afterwards. Thanks, everyone. That'll end the talk.